Seaa 3012, Section 2, Civil Engineering Laboratory 2, Year 21-22, Semester 1, Open-Ended Laboratory, which is our group 13, we will do H1 river flow measurement. Our coordinator is Dr. Kokilavani, anak perempuan An-Namala. This is our group member, Mas Nabila, Alia Fatihah, Ling Ziman, Muhammad Nabil, and Muhammad Najmi. I am Muhammad Nabil Ramadan bin Fazil. I will explain about introduction, theory, and also objective. For the introduction, river flow rate is a measure of how fast river water is moving downstream. It can be indirectly indicated by erosion and water turbidity because as the river flow increases, more particles of dirt and sands are washed from the river banks into the water. Furthermore, measurement of river flow is required for river management purpose, which including water resources planning, pollution, prevention, and flood control. For the theory part, in this experiment, two methods have been conducted to gain the velocity of the flow rate. First is current meter method, second is floating object. Current meter method is the propeller will be put at a depth of water where the maximum velocity and the velocity of flow will be gained when flow water pass through and rotate the propeller. Floating object is a model will be allowed to float on the river through a known distance and the time will be recorded. Velocity will be obtained using the equation distance over time. Cross-section area will be measured manually using cross-sectional method. Then finally, flow rate is calculated by equation Q equal to A times V. Q is a discharge, A is cross-sectional area, V is velocity. And the objective is to calculate stream discharge using the concept of velocity area to determine the average flow velocity of cross-section and to apply the conservation of mass concept at river ridge.
So now I am Masabila will explain the procedure of the current meter method. So the apparatus that we need in this experiment is a container filled with water, a measuring tape, a measuring rod, and a current meter. So next, the first step is we need to measure the river cross-section length by using the measuring tape. So the river cross-section length was recorded. Next step, we need to divide the river into two cross-sections which indicate that one section as upstream and one section as downstream. So next, we need to divide, in this case we divide 5 vertical subsection for this river flow. So next, we need to measure the depth of the river at each vertical subsection by using the measuring rod. So this process is repeated for both upstream and downstream. So all the depth are recorded. So next, we need to set our current meter to the zero reading, and we can use it to measure the river flow at each vertical subsection. And we repeat it at both upstream and downstream. So this step was repeated 3 times as we need to get the average flow velocity. That's all.
Hello, my name is Ling Ziman. I'm going to explain about the floating method in the experiment stream flow measurement. So in this method, we're going to use 4 apparatus, which are the container with water, which represent a stream flow area, a measuring tap, a bottle cap, which we indicate as the floating device, and a stopwatch. So let me demonstrate to you how it works. So for the floating method, first we need to mark 2 points at the stream flow area, which is point A, we indicate the starting point, and point B indicate the end point. Next step, we measure the distance between point A and point B, and then we measure the depth of the stream flow in 3 different positions to obtain the average value. Next step, we also measure the width of the stream flow. Okay, so the next step is when the cap, which indicate the floating device, reach point A, we immediately start the stopwatch, and when it reach the end point, which is point B, we stop the stopwatch. So let me show you. So when the cap reach point A, we start the stopwatch, and when it flow to point B and reach the end point, we immediately stop the stopwatch. Okay, so this process we need to repeat for 3 times to obtain the average value. So from all the data we measured from this floating method, we can calculate for the value of stream flow discharge using the concept of velocity area. That's all for me. Thank you.
For calculation, there are several types of method that we can use to calculate the stream flow measurement. First one in mid-section method, then mean section method, and floating method. Mean section method, the required data is water depth, several readings of velocity for each interval, the length of river cross-section, and the number of river cross-section interval. To calculate this, we must calculate the length of each interval, then calculate the average velocity of each interval, then we make a table which is consists of distance from left bank, vertical water depth, depth measurement, average velocity, width of section, W bar, area, and the flow rate. To get the W bar, we must consider which is the first and the last section, because these two has special formula. To give you an overview, what is W bar, and this is the divided parts for the W bar. The first, second, third, and fourth. For the W bar, especially the first and the last section, we use this formula. This is for the first, and this is for the last section. Then we move to floating method. The required data is distance traveled by the floating object, the time taken for floating object to reach the end, and the water depth. To calculate this, we must calculate the velocity for each trial, then the average depth for the river cross section, then average velocity. After we get all the velocity and depth, we can find the area by multiplying the length of river cross section and average depth of river. Then we calculate the flow rate by multiplying the area and average velocity. This is the example of the calculation. And we move to discussion and conclusion.
One of the crucial aspects of river flow measurement is the recording stage. The accuracy of the calculated flow rate entirely depends on the accuracy of data produced at the station, and the instrumentation used operates efficiently and within the tolerance limits of the specification. There are few types of errors that need to give more attention, which are superior errors, random errors. In order to maintain the data accuracy, we can prevent it by assigning 2 people to read the measurement and reconfirm the accuracy reading. Besides, a regular instrumentation inspection used in this experiment is needed to detect any malfunctioning in its reading scale. From the experiment, we have identified the flow rate of the river using 2 types of methods. From method 1, the current meter, for the upstream cross-section is 0.2097 meter cube per second, and for the downstream cross-section is 0.2947 meter cube per second. While from method 2, the floating object, for the upstream cross-section is 0.362 meter cube per second, and for the downstream cross-section is 0.266 meter cube per second. Therefore, we can conclude there is a slight difference between those 2 measurements due to errors during the experiment, yet objective achieved.